If not, I'm Jeff Fudge, started this user group maybe about 3 years ago. Just because I'm passionate about in the cloud. I'm equal opportunity employer, so to speak, run both the AWS and Azure user group. And as a pre-sales engineer and a director of cloud enablement at a local service provider, talk to customers all the time about their cloud journeys. And I ran infrastructure the old-fashioned way on-prem and all those long provisioning times, and that made me very passionate about the cloud. And I've seen the light, and I drink the Kool-Aid. But with that, I'm going to turn it over to Sam, Elliot, and Matt Atkins, very passionate individuals about staffing in the cloud. They've been a great sponsor for me for both my cloud user groups. And gents, I will turn it over to you.
Perfect. Well, how do we follow that? Very kind. No. So we, as Jeff said, so we got Matt, myself, and Sam. We all work for IO. You can tell by our accents we are British, but we've had some success in the UK and have relocated across to lovely Tampa. Although we're not there in person, we're there in mind, body, everything but physically being there. We specialize just in cloud tech. So Matt and any others that are kind of looking for first jobs, for your sixth job, for kind of any senior management positions, do reach out to us. We'll be able to kind of talk to you about the markets and what's going on. And we'd love to help as many of you as you can when you're looking. Also on the other side of it, we're passionate about tech, similarly to Jeff. So any ideas on future talks, if you actually wanted to give a talk, we kind of want to get more people involved that are attending these meetups and getting them involved in actually speaking at some point. Just reach out and we'll try and facilitate what we can. But yeah, that's enough from me. We'll hand you over to Josh, who's going to talk you through 5 Azure services that you should all know. And I'm looking forward to learning myself as well. So over to you, Josh. Thank you.
Awesome. Well, thank you very much for having me. I'm glad to be here, and it sounds like as I'm having some of the conversations here, the pre-show conversations, I have a bunch of like-minded folks on the on the phone having some entertaining on the call here, having some entertaining conversations. But so anyway, yeah, let's definitely get started here. So this is. I was mentioning right before the call that I do quite a few different talks, and I try to give some variety to some of the communities that I speak with, whether they're reaching out to me or I'm reaching out to them. And by far, this is likely one of my more popular talks, and I think it is because really regardless of where you are, kind of in your cloud journey, right? Jeff was kind of mentioning a little bit about some people are maybe living on-prem, right, still, and thinking about going to the cloud. Some people maybe kind of new to the industry, right? And some people might be, for example, familiar with the cloud from an infrastructure perspective, but they want to kind of understand a little bit more of the developer story. So it kind of touches on a lot of different topics here that are of interest to a lot of different folks. So with that in mind, probably the most boring slide I have here today is the about me, right? This is the least interesting part, but I'm actually from Raleigh, North Carolina, so a little bit north of everybody here, and well. And very west of some people, right? Over in the UK. But I have been really a kind of a developer consultant, what I like to think as a trusted advisor, for over 20 years. Most of that time has been spent in the engineering space. So if there's been really a developer hat, everywhere from being a developer and architect to managing developers, I've worn it. But more importantly, for you folks, I've been contributing to the community for most of my career. So I really enjoy having these kind of conversations. I'm also a Microsoft MVP on the Azure side, which is really kind of reflective of my focus really for the last decade, since around 2010, getting into Azure in the very early days. And then my day job is I'm the global Azure lead on the Appinit team at Cisco. So we build a monitoring solution, right? So I have a lot of cloud discussions, but that's a little bit about me. Let's talk a little bit more about kind of what we're going to cover today. And by the way, this is like a perfect size group from the standpoint of being able to really turn this conversational. So I don't mind questions at all. Definitely feel free to interject. I'll throw some pauses in there, some strategic pauses to give folks a chance to. They're kind of waiting for a pause to ask a question, but definitely don't even feel the need to wait for a pause. Just if you've got some questions, definitely throw them my way. And with a small enough group like this, we can take this talk a few different ways that kind of align with what you folks are looking for. So first off, as I mentioned, when it comes to Azure, Azure is a huge platform. This is what I kind of call the periodic table of popular Azure services, because this is not at all reflective of all the services, right? There's a lot more than this. And so it can inevitably be a little bit overwhelming when you're trying to decide where you should focus your attention. And whether you're new to the industry and you're like, okay, I'm interested in getting started with Azure, or like I said, if you're maybe in a different kind of role today, you're maybe more of an infrastructure person, you're more on the DevOps side, and you want to have a better understanding of services and the kind of some of the decisions that developers are making and where they're aligning, right? So you can kind of get a better idea. But whatever your background is from, this is all about really kind of helping you decide and where to focus your attention. Now, it's worth mentioning that some of the advice that I give along the way here is coming from the perspective of having choice. So it goes without saying that if you're potentially new to Azure development, and there are lots of cases where your boss, your employer, the organization you work for is going to say, thou must use this, this, and this, right? Because you're migrating existing app, and you don't have a lot of choice. You will use Azure SQL, you will use this, whatever it may be. But and obviously from that standpoint, it's pretty predictive of what direction you can go because you have to align well. But if you're really thinking about, okay, where can I make an investment that I know that a large majority of Azure customers will be able to appreciate that investment, because by far they're using platform or service XYZ, right? And that's kind of really what this talk is about. Now, along those lines, there's decision making that needs to take place, regardless of the 5 services, which I'm going to show you that are based on what my experience has led me to. There are some important decision making factors and some questions that you end up asking, and also some questions that you ask, and depending on the answer might drive you one way or another. So before we get into the 5, I think it's important to kind of think about the questions that you need to be asking yourself. And that will help guide you to make sure that maybe you agree with 3 of these and you want to pick something else based on how you answer those questions. So to get started with, obviously one of the first questions you're going to ask is, as a developer, where do I host my apps? So if you saw that big wall of potential services out there that do lots of different things, some of them boil down to specific use cases. And one of them is, and obviously the most popular is, where do I put my bits when I build my code, and where do I deploy it? And where can I run it? And that's one of the questions we're going to ask here as well. And sometimes you want to learn a couple of these, right? Everything from your traditional virtual machines to all the rage today, right? Kubernetes, right? The complexity of Kubernetes. And then everywhere in between, we have traditional app services. We have just straight up containers, serverless with Azure Functions. We even have no-code solutions like Logic Apps. So there's a lot of different options, but you're going to be asking yourself, where do I host my applications? That's going to really help you be able to focus on where to start. The other natural question is, where do I store my data? Right? Almost anything these days needs to persist something somewhere, right? And once again, you have a bunch of options on Azure, right? You have your traditional relational databases, things like Azure SQL and MySQL and Postgres and MariaDB, but you also have some of your other options that are kind of popular and an ever-growing popularity of your NoSQL type solutions, things like Cosmos Database or even table storage. And then even some of your edge cases where, Redis, right? Depending on how long you need to persist something for. So, but you're going to inevitably be asking, after you host something, you're going to be saying, where do I store my data, right? That's a natural question. Now, the other question that is often asked is, what kind of messaging should I use? And you're thinking, messaging, how does this fit in? Well, from the standpoint of cloud native development, right? Cloud first development, cloud native development, whatever you want to call it. Inevitably, most cloud solutions are more distributed in nature, right? They tend to be more asynchronous in nature. And the reason behind this is one of the things that are attractive to so many customers about the cloud, among many, many things. One of them is the ability to scale, right? So that's why, in the traditional world of on-premise stuff, you had your yearly purchase schedule for new servers, and you had to buy all the servers that you think you might need for the capacity you think you might need for the year, right? And then if you ran out, you got in trouble. And so for those type of scenarios where capacity planning was hard, if that was one of your use cases, the cloud is like, hey, it's really, really elastic, right? Well, one of the tenets of distributed applications really is around distributed applications. And when you're talking about distributed applications, one of the best practices around distributed applications is that it is the decoupled asynchronous nature, right? That's how you're able to get a lot of scaling. And to achieve that, the typical path for that is to use some sort of messaging platform, something like a queue, right? And there are lots of options on that on Azure. So when you're building these little microservices everywhere, if that's the pattern you choose to use, and you're trying to connect the two, you're either talking HTTP, which has some complexity, or you're talking messaging. And so inevitably, if you're building any kind of application of any kind of complexity, or that is any kind of asynchronous in nature, hey, I want you to just go off and do something, just take care of it and be done with it. And then tell me when you're done. Platforms like messaging are important, and things like service bus and storage queues and event grid and IoT event grid and event hub. Now, the one thing I will make clear when it comes to messaging, I'm going to give some advice along the way over what type of messaging is a good place to maybe start learning, or that will be very useful for a majority of your application use cases. But when it comes to messaging, messaging is very use case centric, right? So to a certain extent, even though I am going to make a suggestion, if you have a specific use case that is very closely aligned with a different one, then you should use that, of course. None of these platforms, none of these, where you host your applications, the databases, or the messaging is an easy button, right? And they're not intended to fit all use cases, because if they were, you just have one of each, right? And you just, what's the point of having all these other ones? But just to be aware when it comes to messaging that there are specific use cases. And I'll just call out one, and we'll talk about more in a little bit, is if you're having more of an event streaming. So if anybody has ever maybe heard of Kafka, or we have lots and lots of events coming in, right? Versus go do something, go do something, go do something. You're going to more gravitate towards something like event hubs versus something like a service bus or a storage queues, which is more of a kind of a command pattern. I want something done. I want something done. So just kind of keep that in the back of your mind, that none of these are necessarily a good fit for every single use case. And going back to what I said a few moments ago, this is really aligned to what you're going to find is very commonplace, right, in cloud native apps. And so that kind of goes to the questions you need to ask. Another very important question that you need to ask in general before you just kind of pick these 5 is really comes down to, it's a complex question, but at the end of the day, it comes down to how much control do I need, right? And so what we mean by that is that, today, and especially back in the day, pre-cloud, right? You have this concept of on-premise. So there's physical hardware or potentially VMs, but at the end of the day, you own the hardware, right? And you have control over everything. Hardware, software, network, you do everything, right? And that there can be advantages of that, but obviously there's a lot of complexity of that as well. And because of that, that's where we started to move into the cloud, right? With IaaS, right? With infrastructure as a service, and that's really VMs being hosted in the cloud. And you're still responsible for a lot of stuff, but you're starting to be responsible for less stuff, right? I don't any longer have to worry about the physical hardware and some of the aspects of the physical hardware, some of the aspects of the network, but I still have to worry about other aspects of the network, the OS, server config, and all this other kind of stuff. But as we start to get more, we'll just call it cloudy, right? You start to get into this PaaS world. And so platform as a service, which is kind of a generic term for essentially the cloud is managing a lot of stuff for you. And at the end of the day, you're responsible for less things. And it is worth mentioning that I get this question a lot, so I always like to kind of throw it in there. And people may have different feelings about this. AKS is very popular. I got to bring up on every single one because Kubernetes is becoming kind of ubiquitous, especially in the enterprise world with containers and as a target for building applications. And in general, I fit kind of AKS somewhere in between IaaS and PaaS, right? From the standpoint of how much you're responsible for, how much control do you have. And it's worth mentioning, especially in the case of cloud-hosted Kubernetes and AKS specifically, it is ever reaching more and more towards PaaS. So more and more things are being taken care of for you, and more abstractions are being put in place. So over time, I think you're going to see AKS move more and more towards PaaS. But I just like to throw that in there because this definitely is not a Kubernetes talk or an AKS talk, but it comes up a lot, so I like to mention that. And then we get into the serverless world, right? And the serverless world, where really, at the end of the day, everything's managed for us. Of course, there are servers in serverless, but what I like to say, and what's commonly mentioned out there, is with serverless, you think about servers less, right? So that's the whole idea. Everything's abstracted away, everything's managed for you, and you're, at the end of the day, you're just writing some code and doing a little config, and that's it. And then the far end of the spectrum is SaaS platforms, right? And that's where essentially everything's taken care of. It's all just config. And a common example is things like Office 365, right? Where at the end of the day, you're configuring something. You're not really writing any code. But why am I going into this kind of level of detail when it comes to decision making? Well, it turns out at the end of the day that when you're looking at these different platforms, there's trade-offs. There's trade-offs with everything. And one of the trade-offs with having control over everything is that you can't focus on the important things as much. Now, sometimes it's important to have a lot of control. There are use cases where I need to have a lot of control, in which case that's a business need for whatever it is. So it warrants it. But there's a lot of places where you don't need that control. And really you want the velocity that the cloud can give you, because you don't have to focus on all that stuff. Whether you're into infrastructure, you're a DevOps, you're an operations person, you're a developer, you don't have to focus on that stuff. You can focus on the stuff that actually brings business value. And this brings me down to circling it back to those 5 services that I'm about to mention, is they fall within what I like to call the sweet spot here, right? And so the sweet spot that I see, and this doesn't apply just to Azure, I think this applies to all the cloud vendors as well, AWS, GCP, is that for the most part, you're going to find that you'll get the most value out of spending most of your time if you're in PaaS world or serverless world, right? And so that's where we're going to be spending our time for the next hour or so, from the standpoint of focusing on those five services that are super popular, very powerful, very common, that fall within this sweet spot. And once again, that is not intended to say that outside this there isn't a role, and there absolutely is, but you should have a justification for it. If you're not, if you don't have a reason to live outside this sweet spot, you shouldn't do it. I see this a lot today in Kubernetes. I'm a huge fan of Kubernetes. Kubernetes is very powerful. There's a lot of good stuff about Kubernetes, but I also see a lot of organizations who are jumping on the Kubernetes bandwagon and inheriting a ton of complexity, right? And a ton of conceptual and management and operational overhead. And they're not getting much value for it. What are they getting on that return that they couldn't do with PaaS or serverless? So, but once again, we're going to focus here on that. So as I dive into here, starting off the 5 services, are there any questions about the context of kind of what we're going to be talking? And it's okay to be silent. Just wanted to make sure. Strategic pause here.
I'll chime in, Josh. And for my profession, we talk to a lot of companies, and it's amazing how many companies see the cloud as an infrastructure play. And glad you're focusing on applications. I know we're going to try to do that more, but it's great just to have someone preach the fact that, hey, the cloud is not just another data center. You're not just expected to lift and shift and keep developing apps the same way you always have. That, you've got a whole new suite of services and tools. And so I think it's good for us to start having more focus on this and not just infrastructure. So cheers.
Yeah, and that's actually a great comment, because the infrastructure piece, the reason that there's a lot of infrastructure focus, because that's the low-hanging fruit, right? I got a VM on-prem, it's easy to throw it up on the cloud. I don't have to re-architect it, I don't have to rebuild it. So that it definitely has its place. But and you're absolutely alluding to this fact that I think to get the most value out of the cloud, the greatest amount of value about the cloud, is you are making an investment to a certain extent, making an investment in that vendor's implementation of PaaS or whatever it may be, right? and you're going to get the greatest advantage out of going that route from a cost standpoint, from efficiency standpoint, if you build within this, what I call, the sweet spot here. So, but yeah, no, excellent comment. So let's get started.
Well, I have one question before
Yes,
we
absolutely.
go. So I think that the talk is more geared towards the businesses, which is totally fine. But as someone who's building their portfolio, their apps, trying to be cost effective, but still have something to display your portfolio, your projects. Would you recommend the more containerized sections or the serverless PaaS side as far as for cost concerns?
Yeah, and so that's cost is actually a great question. First off, everything I'm talking about here that I'll be talking about this evening, because it is one of those cloud native kind of elasticy kind of services, from someone who's just exploring this standpoint, everything I talk about tonight has essentially either a free or a low cost version of it. So from that standpoint, the barrier of entry of getting to know these things is very low. I couldn't say the same thing if we were talking about Kubernetes or some of the higher end stuff, right there, where just to play around with a little bit, you're going to be spending $50 a month, right? So all of these services are going to be either free or very, very inexpensive. They have tiers for those. But I'm glad you mentioned that, because if you are getting started, and actually I've gotten this question enough times where I think I'm going to add a slide to the end, and I don't have it here yet, but there are some paths in Azure for getting a subscription, either a student subscription where you can get some discounts and free stuff, to a trial subscription that gives you so many credits a month. And then after that, you still have lots of free stuff. There are paths to having low cost and free exploration of Azure, but it's not all the services. But I will say it's all the services I'm going to be talking about tonight. We'll definitely do that. You'll be able to do that.
Thanks so much.
Is that helpful?
Yeah.
Okay, great. And to be clear, from a business standpoint, there's definitely business drivers, being able to focus on business value. And what I mean by that, and it's definitely important to business, right, is that if a company comes in and says, I want you to write widget A, well, the actual writing of widget A, let's just say is 80 hours. But if you have a very infrastructure focused, an infrastructure centric, a traditional infrastructure centric approach to it, you may have 120 hours to set up your environment for building 80 hours of code, right? And the idea behind this is that it's very attractive to businesses, and by relationship, they want developers who know how to do it, right? To be able to build solutions that are very focused on the business outcomes, so that you're not spending a lot of time, playing infrastructure games to get it up and running. But you'll see that here in general, and that's actually a good segue into our first one. So number one, what is the number one service really that you should know on Azure? And that is Azure App Services. Now, Azure App Services was historically kind of a family of services. So you may still see it in some documentation. They've kind of rebranded it a couple of times. You're actually going to see it here in action in a second. And Azure App Services, or if you're in the portal, web apps it comes up as, but it's in the family of Azure App Services, is essentially a fully managed web and API application hosting environment. So what I mean by fully managed is essentially you have your code, you deploy your code, you have a few dials where you can kind of play around with some options that affect scalability, distribution, high availability, but you don't have to worry about the servers themselves. You don't have to worry about the operating system. You don't have to worry about patching. You can focus your solution right within by deploying to Azure App Services. To give a prime example of this, and I think, Matt, this may resonate with you because I'm a .NET developer too. So I'm kind of, I guess we could call it a little bit of a polyglot. I like messing around with different languages. I like messing around with like Golang and a little bit of Python, a little bit of Node. But at my core, my safe space is ASP.NET and .NET, right? And so from that standpoint, if you spin up a new .NET project in Visual Studio, you can literally right-click, publish, not I'm suggesting you right click, you should be using some CI/CD stuff, but you can right click and publish your web app directly to Azure App Services without any code changes, right? And so it supports lots of different languages, and that's the other piece too. And this is where Matthew, I'm going to touch on containers for you too, and kind of help drive that conversation a little bit too. But at the end of the day, it's fully managed, so you don't have to worry about much. You essentially just can deploy your apps there, whether they're ASP.NET apps, a Web API app, a Python app, a Node Express app, whatever it may be. You can just deploy it. Azure App Services has support for numerous languages, not every single one, but all your popular stuff. Numerous operating systems, Windows, Linux, and containers. And so from that standpoint, you can still live as a developer in container world. Let's say, okay, I want to live in container world. I understand and appreciate the advantages of doing all my development in a container, but I don't want the complexity of container orchestration like Kubernetes, which is expensive and complex, and a whole other level of difficulty to learn, right? But I still want to put my web API or my web front end in a container. You can absolutely deploy that container to Azure App Services. So you can deploy just the code, or you can deploy containers, and there's quite a few different options for that. So as you're starting to kind of understand this a little bit, you can see there's a ton of flexibility here, right? Of how you want to develop, what languages you want to use, and then being able to effectively run your server in a high availability, high performing environment. I want to be able to scale it to 10 instances, or I want to use a free tier because I'm just messing around with it, right? And functionality wise, there's not a lot of difference, but I just want to use a free tier right now. I want to have, for production, I want to have, the customer's going to have an instance in New York and an instance in the West Coast, East Coast, West Coast, right? And it just, and it's easy enough to do that, right? So you can distribute it across the globe. You can have multiple instances. So if behind the scenes, you're going to have high availability. So there's a lot of advantages to that. The other thing, and this is from a developer perspective and a best practices perspective, as I mentioned, cloud apps are inherently a little bit more distributed. They're more complex, right? It's kind of the yin and yang, right? So when you get all these advantages of the cloud, but there are some things that make your life harder. Apps are generally more distributed. Monitoring is a little bit harder. And one of the ways you kind of take care of that complexity, especially with distributed apps, is using a CI/CD pipeline, right? So that your code builds and automatically deploys. Well, one of the nice things about that is you can, of course, use Azure DevOps or whatever your pipeline is of choice, or you can use the one that's baked into Azure Web Apps, right? And so you're lowering the barrier of entry to introduce a best practice with your app, and that's all built in. We'll show you that in a second here as well. But if you have some more advanced scenarios, we support that in Azure App Services. So things like virtual networks, you're required to have more isolation. Maybe you're a e-commerce site and you have some of the credit card processing compliancy requirements require isolated. You can have more isolated environments. You can have dedicated instance. So you can start to hit some of your edge cases that obviously have a cost impact, but if you need them, they're there. You don't run into a wall saying, okay, I could do all this until I hit this barrier. Now I'm stuck and I have to go back to the old world. So that is just some of the high level advantages of Azure App Services. Before I kind of jump into and show you a little what it looks like, kind of how it works, and talk about that a little bit more. Are there any questions kind of about the high level over with Azure App Services? Okay. Great, and definitely chime in whenever you'd like. So let's jump in and see what this looks like in Azure itself, right? So I want to go over here. Okay. So I briefly mentioned that I'm a .NET fan, right? And so one of the things that I'm going to kind of keep on coming back to in regards to some of the demos you're going to see here over the next little bit here is this little app. I call it 5 app. You get it 5 functions, 5 apps, 5 whatever, right? I just call it 5 app because I'm not very creative with naming. But just to show what I'm referring to from an app services standpoint is what we're looking at here is essentially if you start this is a .NET Core app. But if you start a new app and just say, .NET new and use the default template, that's exactly what I did here, right? So I took a default .NET project and didn't really do anything super special with it other than giving it a nice little, a simple UI, right? But this is showing that from a development standpoint, all I did was .NET new, created a new template project, and I essentially right-clicked and published this, right? So what did I publish it to? And we're going to come back to this code. This isn't a code-heavy session, but we will show a little bit of code here and there. So what did we publish it to? Well, I'm in the Azure portal here, and I'm in a 5 Azure Services for Devs resource group. So that's obviously a collection of resources on Azure. And I have various resources here. And if you've seen some of this before, you'll start, I'm starting to give you a little bit of a preview of some of the other services that we're going to be talking about here. But if we go into our Azure App Services, this is the standard UI from the Azure App Services. When you deploy an Azure App Services, you get a default URL that Azure App Services creates for us. It's always azurewebsites.net. Now, of course, I could have custom domains and do all that kind of stuff as well, but I'm just keeping things very vanilla. From our standpoint, I have this very advanced website, right? As you can see here, I'm not a UI developer, right? So this is pretty close to one of the default empty templates for .NET. And we're just kind of using this as a basis. So you can see that the website is running right now, right? A couple things to call out here as we start kind of unpacking Azure App Services a little bit. We have a lot of different configuration options. And as I've mentioned before, there's a lot of advanced features that you can do with Azure App Services. Some of those features are restricted to more costly plans. But for the most part, almost everything I'm talking about here, most of the running a basic website you can do in the free. But once again, and I'll call them out a little bit. There are a couple features here and there that are only available to more costly. I wouldn't say they're expensive, but they're not free tiers. So kind of be aware of that. There are some features that give you just some different functionality based on the type of plan that you provide. And that's a good place to start, is that it's important to understand from an Azure App Services standpoint, there's actually like 2 different components to it. There's something called the Azure App Service itself, and then there's something called an App Service Plan. Now, the App Service Plan is the compute. So at the end of the day, there are VMs, of course, running behind the scenes. It's all abstracted away and taken care of for you, but you still have the concept of how many servers do I have and how much memory there is, because it gives you a little bit of information to work with. Well, in this particular case, we have chosen a app service plan that is kind of a middle ground. So if we go here to our app service plan, we can see here I chose an S1, right? And so it's a kind of a standard 1 plan. You can get some basic information about what it's running, how much memory, things that help you understand how well your application's behaving, and whether you maybe need to pick a different app service plan that maybe has more hardware, or you can go cheaper and be more effective, right? And be a little bit more, a little bit cheaper, right? But you can scale up and scale out these. So if I click on one of these, for example, let's go ahead and say scale up. So I chose this S1 plan. At the end of the day, it's a pretty low end plan. It gives you so much memory. This costs $73 a month, right? But it gives you some insights into various features that are available because I chose this plan. Now, if you were cost conscious and you just wanted to play around, I would switch over to a dev test workload and do one of the free ones. It essentially gives you an hour of compute a day. So if your site is only getting hit by you every once in a while, and you're only just kind of playing and developing, this is more than enough. Unless you're hitting the site constantly for 60 minutes, that's more than enough. But there's also some pretty expensive shared tiers as well. But if we go back to our S1, one of the things that it gives us, and that I'm going to be calling out for a demo here, is something called a staging slot. And what is another interesting aspect of Azure App Services, and one of my favorite features actually, are these staging slots. And staging slots are interesting from the standpoint of they give me a pre-production place to deploy my code, and I don't pay any extra for it. Now, of course, I need to be at an S1 or above to be able to do that. If I'm in a basic plan, I don't have slots. So that's one of the first things. But staging slots cover what is very commonly needed for any kind of deployment of production of your applications where you want to have a preview area, right? You maybe want to, some people use it for like a staging environment so they can deploy their code and make sure it works. Some people use it for like a QA environment. Some people use it as a pre-prod where they deploy there and then they balance things out. And if everything goes well, they move over to the production slot. If things go bad, they fall back really quickly, right? People use it for different purposes. But if we go here over here to actually, let's go back to here. Let's go over to deployment slots. So I've already set up a deployment slot for this web application. I want to kind of go through a little bit of a quick demo of what that looks like. So I have a website here, this 5 app. This is running version 1.0, and we can see here from the URL, it is our default 5 app 25448-web, and we're considering this production. Now, I also have this dash staging, and this was automatically created for me, this URL, and you can have custom URLs as well. But when you set up a staging environment, it actually went and set this up for me. And this is actually, if you're familiar with like IIS servers today or multi-tenant servers today, you can think of this as a separate website in the same server, right? And so it's completely isolated. It has its own configuration, and it's isolated, but it's on the same hardware, right? So that's one of the reasons why it's free with a high enough app service plan, because it just comes along with it and it's on the same environment. But as you can see here, this is 1.0 as well. Now let's go through an exercise of what you would do in production, right? Before being able to deploy an app. So if I went back to my code here and we chose this 5 app, and by the way, this is all in GitHub. I'll give you a link to it at the end. All of this sample code is all in the GitHub, and also all the code of how to spin up this environment is as well. But if I were to go in here, we're going to just go in and go to one of our pages, and we're going to go to our default view. And if you're not familiar with ASP.NET, that's and Razor Pages, that's completely okay. But what should be familiar a little bit here is that this is the welcome version 1.0, right, that we see here. Welcome version 1.0. So let's pretend that we did something interesting, right? I'm not going to do anything more interesting than changing this to 1.1. But let's pretend we did something more interesting. We wanted to preview those changes. So if I went in my code and I changed that to 1.1, and then I did another .NET publish, so I want to package this up locally. It's not actually putting it up there yet, but I wanted to package up locally. Now, ideally, we would have some sort of CI/CD pipeline set up, and it would I check in my code and it would automatically deploy it out. So that's kind of the best practice, but we're going to cheat a little bit here. So kind of don't do this for production, right? But it's okay for a demo or if you're playing around locally. So we're going to go ahead and deploy this out to our staging environment so we can get a preview for it. Now, one way I can do this is I'm in Visual Studio Code here. There's some nice plugins for Visual Studio Code. And one of them is the app service plugin. And we can see here that it's picked up my app service. And I can go here to deployment slots and choose staging. Now from here, if I want to, I can say, let's go ahead and deploy to this slot. Now I'm going to go ahead and browse that publish folder that I just created. And this experience is a little bit different if you're in Visual Studio or if you're in a different tool set, but the concepts are the same. And so if we go here and we go to our publishing folder, there you go, hit select, and then we're going to go ahead and deploy. So as this is deploying, we're going to go ahead and go back to our website. And as this is deploying, I'm going to talk through one more aspect of something. And this goes a little bit to maybe getting a little bit more bang for your buck. And this does just take a second to deploy. If you recall a few minutes ago, I mentioned there's an app service and an app service plan. So the app service plan is the actual compute. Those are the ones where that's where you're actually paying for stuff, right? You have designated that I'm going to be in a tier of X that gives me so many features and so much compute and so on and so forth. The app service itself is your configuration and your code. So I'm looking at the app service, for example. I can go in the configuration. This is the same thing as like a web.config or your app settings. I can go in here and set all my app settings, and I can do a lot of stuff. So all the configuration and the actual code to the site is all located here. Now, I can deploy that to an app service plan. But the interesting aspect is I'm not limited to deploying one app service to an app service plan. I can have a higher density environment if I choose to. So if I wanted to, I could have one app service plan, and I could deploy multiple app services to it. So I could deploy multiple apps, completely isolated from a configuration standpoint, from a code standpoint. All the URLs are taken care of for us. You can essentially kind of think of this as, okay, I have in the Windows world, I have an IIS server. I have multiple websites in the IIS server. It's all in the same box. Obviously, all the complexity is all abstracted away from you. I don't have to worry about URLs or routing or proxying or any of that kind of stuff. But conceptually allows you to host multiple websites on a single app service. Now, you still run into the same issues that you do in high density environments where, you know, if you have too many app services running on the same server, right? You can have some performance issues. But if you're looking for high density, or if you're playing, right, and you're like, okay, I can afford to play with, or maybe I get free credits, right? And I can afford to do $30 a month because I have free credits. I have 100 free credits a month, and I can do $100 a month free. I can do $30. That's fine. But I don't want to do more than that. So I can pack this thing full, right, of websites that I'm playing around with. So just keep that in the back of your mind. And I'm only kind of skimming the surface here, really, when app services and the configuration standpoint. But let's go back to our deployment slots. So because we should be good by now. So if we go back to our URL, we can see our production site is 1.0. But hopefully, if the demo gods are happy, the preview site should now be 1.1. Now, can we do this outside PaaS? Sure, but it's a lot more work, right? This is a very common need, and it's a lot more work. I got to set up another server. I got to set up a load balancer. I got to play load balancer games. I've got a lot more work to do. I can totally do it, but it's a lot more work. And I'm probably going to be paying for the other server. I'm probably going to be paying for an extra load balancer. I have all the complexity around that. And this is really just kind of an easy button way of doing this. Now, let's pretend that everything's happy. 1.1 is freaking awesome. Our QA department is raving and they want to get into production. Well, we have some different options about getting in production. I'm going to take the quick one and just say, hey, let's swap it. And what it'll do behind the scenes, the complexity of dealing with maybe DNS updates, the load balancer, and keep in mind, this is pretty simplistic right now because I only have maybe one instance I'm running because this is just a demo. There could, you could go upwards of 20 servers running behind the scenes here, right? And all of the swapping of all of those environments and where URLs are hitting are all taken care of for you. Now I'm doing a straight up swap, but let's say you want to take a different approach and say, I want to do more kind of A/B testing, right? I want to say, hey, I'm going to send 20% of the traffic to staging. And so for a little while, they'll both be accessible, right, to the same URL, but some of the traffic will be going here. And you can kind of get that canary testing, right? Where you can say, hey, not really A/B testing, more canary testing. You can say, hey, am I having some issues here? And then quickly say, no, let's roll back. I'm going to kind of, I'm pretty confident in this, right? And so I can go in here. And the other takeaway here is, as you can imagine, if you're using this as a pre-production environment, most of your settings will probably be the same, right? But if you're using this more of QA or a staging environment, or even like a dev environment, although I wouldn't suggest that if you're just playing around, because remember, it shares the same hardware as production. So I usually caution against having like a dev environment because it's running, you don't want to impact your production. If you're running, for example, a load test on your dev environment, you're going to impact production because it shares hardware. But the takeaway here is that settings can sometimes need some flexibility, and you can actually create slot-specific settings. So you can say, okay, this setting stays in this slot. So no, if you swap slots, the staging slot always is pointing to the staging database, and the production slot is always pointing to the production database. So you can have some intelligence around that, and we'll go ahead and hit swap. And this just takes a moment. Now, the interesting thing it tries to do this intelligently, right? It'll slowly bleed off traffic. It's not going to kill connections. And it'll slowly bleed off traffic and slowly ramp up traffic in the other direction. And it does that along the lines even if you have multiple instances as well. I'm going to give some advice here at the end before we move on to the second one, but the second service or platform we're going to talk about tonight. But keep in mind that it's trying to do this intelligently. And it's running a little slower than it usually does. And that's probably because I'm showing it. And that's usually what happens when you're trying to show something. It goes slower than it should. But in a moment here, and if it takes more than a moment, we'll come back to it in a second here. If I refresh this, no, it hasn't swapped yet. So we'll give it a second. We'll come back to it. We'll come back to this in a second. Let's go over some best practices real quick. And then we'll come back and we'll show that because it's just taking an extra second. Now, this obviously really just skims the surface of what Azure App Services is. But it should give you an idea of kind of the power behind the platform and the flexibility behind the platform. You know, of course, I didn't even really touch on some of the things I spoke about from a feature perspective, because we're trying to hit a bunch of different things tonight. But just kind of be aware there's a lot of settings here, and there's a lot of configuration that is open to you to kind of meet your needs. But let's go back to some best practices around that, and then we'll show that. I'll show you that in action here in a second, because it should be done when I'm done with my best practices. So a few tips, right? So things to think about when you're working with Azure App Services. A couple things. Obviously, use deployment slots. I actually was talking with the Azure App Service team at Microsoft just a few weeks back, and they're still surprised with how few customers are utilizing deployment slots when it's literally a free feature for the majority of production customers. And there's no doubt that's very heavily used, but they're surprised it's not used more. And because it is a very, very useful feature, right? And some people they just don't know it's there, right? But so in regards to deployment slots as well, there's also a feature called Appinit. And Appinit allows you to cover those scenarios where if your application has some warm-up stuff it has to do. So you don't want that first hit coming into when you swap a slot to be really slow. Like it's like, oh, the slow user experience, because they're getting the first hit and spinning up a bunch of stuff. You can make sure those things are warmed up by using something called Appinit. There's also some features called local cache that allow you to essentially cache some of your application artifacts is the word I was looking for. Things like your local DLLs, images, HTML pages, all those kind of things locally on each instance, as opposed to sharing them in centralized storage. And sometimes that can actually make a difference of a few milliseconds, which can be important. One important thing is if you're using a lot of socket calls, and when I say socket calls, let's say your front end in the code behind is hitting web APIs downstream. It's hitting an API service. There are some smart things that you should do with that to make sure that you're effectively making use of all those connections, because at the end of the day, there's still servers behind the scenes, and you can still run out of essentially socket connections. And that's well documented on the Azure App Services site around some best practices. But keep in mind, if you are instantiating in the .NET world, if you're using HTTP client, there's some best practices around it. Also, and this is more production than if you're playing around, tinkering around, and toying around, you should use at least 2 instances. As I mentioned, all of the Azure App Services is fully managed, right? So Microsoft and Azure take care of all the patching, all the updates, everything. Well, it has to do that at some point in time. And so what it will do automatically for you behind the scenes is spin up a new instance for you, copy all your stuff over there and switch you over. And that way, you don't have to deal with patching outages caused by patching, because they'll actually behind the scenes move you to a new instance that has a new patch on it, and so on and so forth. But that can still cause kind of like that can still cause a little bit of a blip. It won't cause errors, but it might cause a little bit of a cold start, because not really a cold start, but we'll call it a warm start, because something still has to spin up, right? But if you have 2 instances behind the scenes, so if you've gone into the portal and go and choose scale out, and I've chosen at least 2 instances, it does some intelligent things for you behind the scenes. And if you've noticed from this screen, this is the way that you scale out, which you can manually scale out or auto scale based on a schedule or metrics coming in saying, okay, if all my servers are maxed out, give me another instance. There's some intelligence that you can add to that. And lastly, and this is just the best practice, you notice that I opened up configuration there, and there's probably some stuff in there that probably shouldn't be shared from a key standpoint, from a credential standpoint. Put all of your secrets in Key Vault. Key Vault is a secure configuration store, and there is native integration with Azure App Services. It's well documented. It makes it really easy to store all of your important stuff from prying eyes. Just because they have access to the portal, you can't copy and paste it out. It's all done at runtime. Definitely use that. So with that in mind, let's go ahead and let's see if the slot swapped. So if we go to our production site again, we should hopefully see 1.1 here. And there we go, 1.1, right? So it went a little slower than it usually did, but that is Azure App Services in a nutshell. And as I mentioned, there's a ton of flexibility there. And I'm not only recommending it from a flexibility standpoint and from all the features and all the benefits to you as a developer. It's really low hanging fruit. If you're doing .NET development, Python development, whatever it may be, it's really, really easy to work with Azure App Services. You can do it for free with a free tier. It's plenty to play around with. You won't get slots, but you can still get pretty much everything else with a free tier, and you can work with it. It is also worth mentioning, one of the reasons why I recommend it is because it's also the second most popular platform in Azure. So it's very likely if you're working with a customer or you're looking for customers to work with, and they're on Azure and they're looking for Azure expertise, it is exceedingly likely that they're using Azure App Services, right? I can tell you from an Azure perspective, it's the second most popular hosting platform beyond VMs. VMs are still king across the whole cloud, right? For good or for bad, it is what it is. But and I can tell you even for the company I work for, AppDynamics, we monitor lots and lots of workloads. We're the biggest monitoring platform, today. And so I get a chance to see lots and lots of different environments, and our experience lines up with it as well. Almost every single customer that is an Azure customer of ours is an app service customer. So it's a good place to invest your time. It's a good platform to understand. It's an easy platform to get started with. So before I move on to the next one, any questions on Azure App Services? Okay, so let's go ahead and continue on to number 2 of the services that you should know. So service platform number 2, Service Bus. I was kind of alluding to the fact that I mentioned it a few times that, the messaging is the glue that ties together applications, modern applications, right? And for the most part, when you're tying together these typical modern distributed applications, you could think of them as microservice applications, or it could be an inter-application dependency. You're either talking HTTP, which have its own levels of challenges, right? I kind of cry a little bit inside when I work with a customer and I see their applications making long HTTP chains, and they're all asynchronous, and I kind of cry a little bit because that's actually like the exact use case that Service Bus is intended for. And so what is it? It's a fully managed cloud messaging platform, right? So it supports concepts like queues and topics. So you can think of queues, if you're not familiar with the kind of messaging pattern. Queues are like commands, right? So I'm going to put a command into a queue to get some work done, and I'm going to have listeners, consumers of the queue, that can then pull that out, do that work, and it's all done. You don't have anybody waiting for it, right? And that also enables you to scale pretty effectively because you don't have on these blocking calls waiting for something to get done, right? At the end of the day, it does add some complexity in handling the end result of that. You may have to have some sort of process that goes back and checks the result. But a lot of times queues, operations that take place in queues are long running anyway. And you think for example of you're in Amazon, right? And you check out, right? You're not sitting at the page hitting refresh, right? It goes out and does a bunch of stuff, and every once in a while you'll go back to the site and it's now been shipped. Oh, it's now out for delivery, right? And these are all asynchronous operations that are common to distributed platform. That's kind of the use case for this. Topics are a little bit different. Topics are interesting. They're more of events. So a topic is like, okay, something happened, and I don't care what you do with it, but I'm just going to announce something happened. And the prime use case behind topics, and one of my favorite ones, is extensibility. So imagine going back to the e-commerce use case where you have a checkout, right? And now you have some new feature that the business wants you to write when anybody checks out, something from their shopping cart. Maybe some special analytics. They want to go over and do something special, right? But they want to wire into when a checkout occurs. Now, back in the day, you'd probably open up the checkout event in your code and start adding more lines of code of things to do, right? That has the impact of everything running longer. It has the impact of, you could error things out, lots of things, right? A better approach, and this is where topics and what is traditionally called pub sub is you're subscribing to a publication is a topic. And you can say, okay, I met an event, anybody can listen to it. All you got to do is subscribe to it, and then you can run whatever code you want to run. I don't care. And so it supports both of these kind of concepts, but it also has very powerful enterprise messaging features and options as well. And this is one of the main reasons between the topics and this feature, some of the more advanced messaging options, things like transactions, things like, hey, I want certain messages processed in a certain order for whatever reason, right? Some of these more advanced concepts are available if you need them. And it's these last two things that are really the reason why this is number 2 and not something like a more simple messaging platform like storage queues, which is very cheap and very simplistic. It's only queues, but it's missing some of these common features that are very common in the enterprise. So if you're familiar with Azure, you're thinking to yourself, why didn't you pick storage queues? Because that's really cheap and it's really popular, which are both accurate, very accurate statements. I picked this because of the versatility of the platform and that it's very enterprise ready if you need it. And once again, remember that sweet spot. It is fully managed, right? I don't have to deal with a lot of issues. And it can be built and scalable. So that's one of the challenges sometimes with storage queues is there's not really a built-in mechanism to kind of distribute them, to fail over if a region goes down. Some of the more things that you would want with an enterprise high availability app, you have some work to do with storage queues of managing that yourself. And this is just kind of all baked into Service Bus, right? And we're actually going to build on the Service Bus topic in the number 3 because it's so important, this messaging topic. But before I go ahead and jump into a little bit of show and tell, does anybody have any questions around Service Bus or messaging in general?
I was just going to ask what the default sort of failover options are for the message bus there.
Yeah. So why don't I? I'll show you.
Okay.
So
I think I read somewhere like you get two by default or something like that in different regions, but I can't remember what they were.
Yeah, so there are definitely some different options, and there are also, like everything else in Azure, there's tiers, right? And so you have like a standard tier and a premium tier, and you get some different things from those tiers. So if I go here, and let's go back in the portal, and we can see here, if I go back to Service Bus. So I have a Service Bus namespace. So a Service Bus namespace can hold onto topics and queues. And so if I open up this piece here, right, we can see here I can get some high-level information. Now, the one thing that I will call out, and this is kind of going back to the scenario in regards to cost effectiveness, right? So this is a they have a couple different plans, right? And if you are in the low-end plan, you will not have topics. It's queues only. So, excuse me, if you spin up a new Service Bus namespace and that is missing topics, you're like, I want a topic. You pick the low-end tier. Now, this is still pretty cost-effective. We have demo environments that run this at a much faster clip than you would do as like a local dev environment. And I think, we're paying like $12 a month and $11 a month. And so it's very cost effective, especially if you have some free Azure credits. But if we go to, for example, Geo Recovery, so it allows you to fail over your namespace to a secondary event data center, right? And that's really what this is about. So it is not a geo distributed platform. And I don't think I can, it's only premium. That's what I was about to say. I was pretty sure. And that was one of the reasons I delayed answering your question as well, because I was pretty sure it was premium, but I couldn't remember, is that it is only available in the premium tier, but it essentially allows you to have that geo failover, right? And that really comes into play when, if anybody is familiar with Azure, just like AWS, it's had its outages over the years, right? Had a pretty famous one, I think, a couple years back or last year, where South Central US, there was a lightning strike and it blew out something, which blew out an air conditioner, which caused half of a data center to melt down before it could automatically shut down. And it was a mess. And Azure found out that it had some dependencies on that region that it didn't know it had. And so Azure AD went down. It was just a big mess, right? But in those kind of scenarios that are rare, but they do happen, you can have this essentially geo-replicate over to a region of choice. Does that answer your question?
Yeah, that's great. Thank you.
Yep. Okay. And that's the one thing that's an interesting, more of a trivia thing behind the scenes is that Azure Service Bus, I think basic and standard, it's the basic one that only has queues, standard has queues and topics, and then there's premium. They look all alike, but interesting enough, behind the scenes, the premium, the infrastructure that drives Service Bus behind the scenes for premium is actually totally different infrastructure than what runs on standard and basic and standard, I'm sorry. And that's what enables some of the features that you get with Geo Discovery. There's a lot of common asks from the community to say, hey, this is only a premium feature. Can we at least please get this premium feature on standard? And universally the answer is no, sorry, we can't do that. And the reason behind some of that is because the actual infrastructure behind the scenes actually looks very different. And the infrastructure is different because it enables them to support things like Geo disaster recovery and some of the other networking kind of options that the premium has.
Does that mean that if you upgrade from a non-premium tier, there's an outage, you have to tear it down and rebuild because it's on a different?
Nope, not at all. That's why they have this migrate to premium. So for that exact reason, you don't want to tear things down, right, and recreate it.
Yeah,
they do have a migration
the APIMs have that issue. I was just wondering if it's a similar issue.
They do, and I'm a huge fan of API management, but it does have some challenges with that. And some of the, and even with API management, it's not on my good list for the last week because like I tried to spin up one the other day, and it was like 3 hours to get an instance. I was like, come on, you're killing me.
I was just wondering if it was subject to the same thing, but you're saying
I think I'm not as familiar about behind the scenes with API management, but I suspect so. API management has some heavier infrastructure that drives it behind the scenes, so I suspect there's more of an actual physical move of things, right?
So we had a consumption plan, and then we wanted to go to a basic or standard plan, and you have to basically kill it and recreate it.
Yeah,
I think you can go up. You can go up and down in the basic, standard, and premium.
Yeah,
but if you come in from or to the consumption,
the consumption I've heard, and I don't know this firsthand, but I've heard the consumption for API management is kind of like a different hardware too. That's what enables it to kind of like scale. So it's on a different infrastructure behind the scenes too. So it takes, and I haven't tried. Were you able to migrate it? I didn't think you could.
No, that's what I'm saying. You can't migrate it. You have to.
I thought you said you did.
Yeah.
Okay.
No, you have to destroy it to migrate it. You have to tear the consumption one down. And that's why I was asking if this was a similar thing.
Yeah, you got to export all your stuff. Yeah, that's pain.
Yeah. You've got to kill it, recreate it, and it can take 40 minutes or more, like you say, 3 hours maybe.
Yeah, and I actually touch on briefly on that consumption piece, but I'll circle around. But I was about to mention something, but I'll save my thought for number 3 because I actually touch on something on that consumption with API management that is challenging. But this is messaging. The messaging in a nutshell. We're going to see it in action here in a moment when I talk about the next piece. But just kind of keep in mind some of the pieces around messaging, and that from a messaging standpoint, obviously, and from a developer standpoint, if you're building distributed applications and you're building scalable distributed applications and you're using common enterprise patterns and best practices, it means you're likely, very likely, going to be using some sort of messaging platform, and you will get a lot of bang for your buck, right? With Service Bus. With the caveat, if you're really cost sensitive and all you need is queues and you don't mind some of the stuff, then absolutely take a look at storage queues, and they'll give you a good bang for your buck for, I don't know, probably pennies on the dollar. But you can't go wrong. You cannot go wrong with Service Bus. And once again, kind of going back to my day job, which I'm absolutely not here to promote my day job, but it has some very useful experiences I've gotten from that. Is that we work with a lot of enterprise customers, and by far we see Service Bus an absolute ton. So with that in mind, let's go on to number 3 because it kind of builds on this topic here. Oh, actually, before I do that though, let's hit real quick on some Service Bus tips. A couple quick things. Don't forget there are actually multiple protocols available behind the scenes. So if you're just using the SDK, you don't have to really worry about too much about what protocol I'm using, right? It'll use like service bus messaging protocol. You can use HTTP. But the interesting aspect is if you have some existing code out there, right? Or maybe you're in the Java land, right? You're making a Java solution where I already have some generic stuff based on AMQP, which is a messaging standard. At a protocol level, I don't have to implement SDK or anything. If I can talk AMQP, I can talk to service bus. So keep that in the back of your mind. It kind of varies depending on what platform you're developing with, but that's good to know. A little careful on SDK confusion. There's been some different versions of the SDK over the years, especially confusion between .NET and .NET Framework and .NET Core. And I think it's mostly settled out, but it was like the bane of my existence for a while because there's a bunch of different SDK versions out there. And in between the SDK versions, they actually rename some of the classes like message and message broker. And so you will see example code out there for one or the other and go, why can't I find this? And why is this example working? And this won't compile and I can't find my namespace and all these issues. And you realize you're out of sync with your SDK is out of sync with whatever code sample you're looking at. So keep that in mind. Just like any other development best practice that is using some sort of client connection type, SQL connection, HTTP connection, those kind of things. You want to try to reuse your client connections as much as possible. The same thing applies here. You'll have lower overhead. Async is your friend. This is asynchronous in general. You should, when you're dealing with the SDK and the code, make them asynchronous calls so that your calls out to your service bus and your messaging are non-blocking. So that's very important. So I still see that a lot. I see synchronous calls to service bus. It may be because of an old SDK, but if you're using a newer SDK, use async. Remember to batch your requests if you can. So you'll get better efficiency out of that. And also don't forget about more of your advanced features. Don't use them if you don't need them because there are restrictions and they add overhead. But if you need transactions or message order is important to you, definitely use them. That's what they're there for, right? So with that in mind, let's go hit number 3. And number 3 is arguably my favorite one, personally. And it's going to build on what we're seeing here with Service Bus. So number 3 is Azure Functions. So Azure Functions is the premier Azure serverless platform. There are other serverless platforms on Azure, but this is really the premier serverless compute platform. And what do we mean by serverless? Obviously, as I mentioned earlier, there are servers. I think everybody gets that now. The joke has gotten old. I've been talking about serverless since like 2017, and I used to have 2 or 3 slides to introduce what serverless is and what it isn't. But these days, it's become a little bit ubiquitous in conversation. So most folks know that when it comes to serverless, it will scale, not to infinity, but it will scale to meet your needs within some limits. And there are a lot of cost benefits at times in general to serverless because, among other things, you don't pay to keep the lights on. So these are great for things that are like occasionally run APIs, occasionally scheduled tasks, occasional stuff, or very spiky stuff. Only runs on weekends, only runs in the evenings, only gets hit a few times a day. I just want to play around with it. I have an API that's used by a small app, and I don't want to pay really to host another API. And it gives a very healthy option of free. You get like 1 million hits a month, I think, across your subscription. And you'll pay a few pennies for a little bit of storage, and that's about it. The important takeaway here, however, is it is an event-driven framework. So the trigger there should be framework. So framework means you have to implement the framework. And so what this means is if you are for example, a .NET developer today and you like building web APIs and you're like, hey, I want to host my Azure function. I want to host my API in Azure function. You have some work to do. You can't just run an ASP.API web API in Azure Functions because to get the advantages of Azure Functions, you have to use the framework. Now, the framework's really easy to work with, and it has a variety of programming languages, and it has some advantages in those programming languages, like .NET and Python and Node and even PowerShell, right? It supports. And so I feel like I'm missing one there. I know I'm missing one, but anyway, there's also the framework also, and you'll see this in action here in a second, also adds some nice features called bindings that allow a lot of common tasks to be quickly done without a lot of code, right? And it also is, and I'm not going to touch on this because it's a fairly complex topic, but there is an aspect of Azure Functions called durable functions. And durable functions essentially allow you to write workflows within Azure Functions. And those workflows can be asynchronous, right? They can be long running, things that you would not normally apply to serverless, because in general, serverless, with all the goodness, does have some limitations. One of the common limitations is execution time. You have limits on generally you have limits on execution time. Now, it's also worth mentioning that Azure Functions have different tiers like everything else. And you almost always hear in serverless, oh, there's always an execution time limit. Well, in Azure Functions, you can actually have a certain tier that doesn't have limits. So Microsoft has gotten really good at identifying some of these edge cases where some of the normal limitations of serverless are negated by paying a little bit more, but you're allowed to get all the benefits with just a little bit more cost, and you no longer have things like execution time limits. The other thing is often the case is something called cold starts. So one of the ways that you can, Azure Functions is very cost effective, is that when it's not getting any hits, there's nothing there, right? So when you need something there, it takes a little bit of time to get something there. And that's referred to as a cold start. And so after a while, when there's no activity, serverless will scale to what they call 0. And when it scales to 0, there's no actual instances running. There's still the kind of listener in front of it, and that's part of the plumbing of Azure Functions, but there's nothing that drives it. And so the first request comes in and it has to say, uh-oh, there's nothing there. Hold on a second. Let me spin it up. Okay, now you can go. And that's referred to as a cold start. There are some techniques to get around cold starts, or if you don't mind paying a little bit more, Azure Functions Premium aggressively addresses cold starts by having some pre-warmed up VMs behind the scenes. And when I say VMs, you don't have to really worry about their VMs. Their instances behind the scenes is probably a better term. At the end of the day, everything is a VM, even if it's a container running on a VM. At the end of the day, everything's a VM. But keep in mind that, and why this all comes back into business process orchestration or workflows is that because of some of those restrictions, there's a lot of common use cases that may have been challenging to work with, especially like, hey, do this, then go do a bunch of stuff, then do this, or maybe things like what they call are like common patterns like fan in and fan out. So let's say I have 100 things to be done, and I want all those 100 things to be done at the same time, which is a fantastic use case for serverless, right? Let it scale out to meet all those needs and process them all at the same time instead of one right after another. So I can do something that would have normally taken, 10 minutes and now takes, 800 milliseconds because it's all being done at the same time. But the challenge is I need to know when they're all done and figure out if any of them failed and hold some sort of state so I can figure out when they're all done. You could always do that. If there's some complexity in code, you got to write it. And it's use cases like that durable functions steps in and takes care of all that for you, but still keeps it all serverless friendly. So it's kind of a layer of abstraction. It persists some things behind the scenes. It's persisting to actually table storage, and it's still using queues and things behind the scenes to make sure that we're not breaking any serverless rules. Things are not executing too long, and we're still doing things in a scalable way. And we don't want to pay extra for them, key, right? We don't want to pay for while something's just waiting to do something. We don't want to pay that or to use up our free stuff more likely. But it does it in an intelligent way. But I definitely suggest if you have a use case where you have some kind of workflow-ish use case, then definitely look at durable functions. And once again, just like Azure App Services, it has its own CI/CD pipeline. And that's the first thing. And the last thing I'll note in regards to that is the reason why it looks a lot like Azure App Services is because Azure Functions is kind of like a sibling to Azure App Services. So Azure Functions actually utilizes the same infrastructure behind the scenes that App Services uses. And because of that, they also share a lot of features and they share a lot of configuration in the UI. So a lot of the stuff, not everything, but a lot of the stuff that you do see in Azure App Services is also available in Azure Functions as well. So before I jump into some demos in this regard, any questions around a high level around Azure Functions? Okay, great. So let's jump into back into a little bit of code here. Let's talk about a little bit of our use case so you can see a little bit of this in action. So if we go back to our code here, and once again, this is all in GitHub, right? So you can look at it yourself. I have created a new Azure function. Now, if you recall, Azure Functions is using, let's close all this stuff out. Azure Functions is using a framework, right? And so I need to implement the framework. Well, what's the best way to do that? Well, there is an Azure Functions core tools that you can install, and you can install it. It runs on Windows, Mac, Linux, whatever it may be. And those core tools give you all the features that you need to run Azure Functions locally. And that's one of the differentiators from some of the other cloud providers is the Azure Functions runtime is actually open source, right? So I can actually go and look at the code. It's not IP of Microsoft. It's open source. And the other thing about it is that the Azure Functions runtime I run locally is the same thing that runs up in the server, right? It's not like a mocked up version. It's not an abstracted away that behaves the same, but it's not really the same. It's the same thing. So you have a high degree of confidence that what you're running locally is actually going to run the same way up on the server. And so with that in mind, I'm actually using Visual Studio Code, and I'm using some extensions for Visual Studio Code that I've used to build out this. And what I've done, and I'm not going to go through all of it, of course, here, just for the sake of time, but be aware there are some extensions with Visual Studio, and with Visual Studio as well. If you're a Visual Studio fan, you can see I have this Azure Functions plugin extension, and it gives me a bunch of features, and it's allowed me to kind of build out a quick project here. So I've initialized a project, and in this particular case, I have built a project that I want to show this one. This is an example of a web API. So one of the first things I mentioned, I kind of failed to mention a little bit earlier, I implied it, but I didn't specifically say it. Azure Functions is not meant for front end, right? So if you're building a web app, you still need someplace to host the UI for that web app, right? Whatever kind it is, you still need a place. Azure App Services is a great place to host it, but it needs to be hosted somewhere. Azure Functions is really for the backend stuff, right? This is for maybe an API that the web app is using. This is maybe to process message queues, messages that are coming in. And that's the use case that I'm going to show right here. So at this point in time, this is what's referred to as a trigger. A trigger is an event. Remember, this is an event-based framework. So this event, it'll trigger an event. In this case, this is an HTTP trigger. So this is an API event. So this is an HTTP request coming in. This looks, if you're familiar with .NET, this looks a little .NET-ish because it is .NET-ish. So there's a lot of commonality between the web API work you may have done and what Azure Functions looks like. Obviously, if I pick Node or Python or whatever it may be, that code's going to look very different, right? But this should be familiar to a .NET developer. And this is referred to as a trigger. And this is based on an attribute. And this trigger is bound to this particular HTTP request object, and I can interact with HTTP request. It can actually be bound to different types of objects. If I wanted to bind this right to a model, it would automatically do the serialization for me. I'm just doing it here by hand because I choose to do that. The other piece, and I alluded to it earlier about bindings, is this concept of bindings, which allows me to very easily interact with common services. This is an example of a service bus binding. In this particular case, I have a binding that is configured to talk with a queue, and here's a connection for the connection information. And I am binding it to this particular queue collection. And so from that standpoint, all I have to do, instead of writing 15, 20, 25 lines of code using the Service Bus SDK and adding the Service Bus SDK to this, all I have to do is throw, in this particular case, a class that'll serialize to some JSON behind the scenes of this type into this collection, and it's taken care of, right? There's nothing that prevents me from using the SDK if I have some more advanced scenarios that maybe the binding doesn't support. But the nice thing about the binding is, once again, going back to that big graph I showed with the business efficiency, right? With that big blue, right? This is allowing you to focus on the things that matter, right? And if I can save 25, 30 lines of code over and over again, and that's code I don't have to support, that's likely not buggy, and focus on other stuff, that's the way to go, right? And so within just a few lines of code, I have an API endpoint, and with just this line of code, I'm dumping it into a queue. So that's the idea behind Azure Functions, and this is conceptually what it looks like. On the other end of the spectrum, and we're going to show this in action here in just 1 second, is a request queue trigger. So in this particular case, this function will fire anytime a message comes into the request queue. and it's using this connection. And if you remember before, I used that request model. Well, I don't want to like deal with raw bits, right? Unless I have to. I rather just give me the object that represents the message in there. And that's what's going on here. And so I'm going in here and it's just automatically turning that message into a nice pretty object because it's just JSON behind the scenes. It's doing serialization for us. And then I'm using a different binding, which I'll talk about here in a second, to save it to a database. And so I have created a very distributed, friendly sequence, right, of activity with just a few lines of code. But let's see what this happens, what this looks like as it's going through the actual application. So if we go back to my super advanced 5 app, right, you might have been wondering, hey, what's this thing doing? Well, at the end of the day here, this is a little piece that allows me to specify how many messages I want to generate. A little trivia bit. I was showing this to my coworker last week, and I usually keep this site shut down. And he asked, "What would happen if I put 1 million in there?" I said, "It would probably try to queue 1 million messages. So please don't do that in this site right now. You'll cause me a big bill." But little interesting note on unintended consequences, right? But it's one lesson that is very, very useful to demonstrate when it comes to serverless is that one of the issues that you may have with serverless is that it will scale to meet your needs. If you are under a denial of service attack and you are getting a lot of requests coming in, I think someone labeled it like denial of billing or something like that, and you're hitting a serverless backend, you could have some unexpected cost involved because it will try to scale to meet your needs. And at a certain point in time, even as cheap as Azure Functions is, anything at scale can become expensive. So keep that in the back of your mind when it comes to serverless, that it's always good to have some checks and balances. And you can actually set up budgets and you can set up limits on Azure Functions. And I highly suggest you to do that so that in case, for example, you accidentally run a load that you don't need to, and you run a load that you think is running for 5 minutes, and you go to lunch and you realize, and you get caught up and you realize the load's been running for 5 hours, and you get surprises. So make sure you put up some budgeting restrictions and some other things, some checks and balances around Azure Functions and around serverless in general, and really anything that can scale, to be honest, to kind of prevent those unintended surprises. But if we go ahead and make this request here, I should probably do something interesting with like a status, but I'm not. And it's just go ahead and make the request. So if we go into, for example, our Azure Functions, so going into Azure Functions here, I'm going to open up this function here. This is an Azure function. And if it looks a lot like what I was just showing with Azure App Services a few minutes ago, you're right, because it looks like Azure App Services. Is there a question? Or was that just a sound? Okay, great. I just want to make sure it wasn't a question. If we look at this Azure function here in the portal, we can go, and we do have some unique elements here that are unique to functions that you won't obviously see in Azure App Services. And if I choose functions in here, it'll show me all of the triggers that have been, and their types that have been uploaded because I published my code here. And in the case of HTTP triggers, I can actually go in here a little bit, and I can actually play around with some of these HTTP triggers. I can kind of see things in action. And this is behind the scenes a definition for the trigger, but I can do some test runs if I want to. And that's kind of useful for some poking around. But interesting enough, I can actually see logs real time coming in. Okay, just tell me the default time. So if I, for example, if I go back here and let's put another 25 requests in, I should see, yes, I can see my, basically my output that's happening behind the scenes of these requests coming in. So that this is semi-useful, but we'll go into a better way of doing this later. But if we see these requests coming in, I can see here, for example, that, went too far here. Let's go back to our service bus namespace. If we go to our queue and look at our requests coming in, and we can start to see, we've gotten some requests coming in, right? In the last hour, you should see a few bump up here. As soon as it loads up. But that's kind of how easy, right, it is to build with a combination of Azure Functions and Service Bus to quickly build a truly distributed asynchronous, loosely coupled, right, tier or service with those two, and between the two of those, just playing around with it here, kind of going back to, hey, what's the cost of this just to toy around? This would be at no cost really for Azure Functions. And if you toyed around with this a few times a month, I would probably bet you'd probably pay about $10 for Service Bus. So just kind of keep that in the back of your mind. Once again, if you're really, really cost conscious and I wanted to play with something essentially almost free, pretty close to it, I would just change this conversation to use storage queues and just look up that. But so let's talk about some best practices behind Azure Functions. Well, obviously avoid long running functions. So if you have something that's running for a long time, it's not really a super good candidate, or it really likely means that you need to break it into pieces. You're trying to do too much at the same time. So instead of doing 10 things all at once, put 10 messages in the queue and let it take care of it that way. And if you have some complexity on how those 10 messages are orchestrated, use durable functions to do it, because it means that you can have long running stuff as long as you can break it into pieces without breaking the rules of serverless. Obviously avoid internal state, because it doesn't keep internal state, once again, unless you're using durable functions. But if you just put something into a variable, even if you put it into static, it will likely not be there. There is some instance sharing, some static variables are helpful at times, but you wouldn't want something that, because you can actually have multiple requests come into the same instance of an Azure function behind the scenes, but you don't want to actually store state there. You don't want anything that you have to depend on. Once again, HTTP client, that socket thing I talked about, is even more important here, because you can absolutely generate tons and tons of traffic, obviously, with Azure Functions, because it can scale, and you could run into some socket issues. As I mentioned, consider premium. If you're worried about those cold starts, or you want no execution time limits, or for whatever reason you want some beefy hardware, you can actually specify some beefier hardware. Maybe you have some memory intensive task. I'm not talking like video processing or any kind of thing, but if you have some memory intensive task, and it'd be valuable to have a little bit more memory, up to like 14 gigs of memory for your instance, sometimes you should consider premium, because you can play around with what level your hardware is running at a little bit. Keep in mind you can have concurrency configuration as well. And what I mean by this is serverless is great, but one of the big problems with serverless is eventually downstream it runs into something that doesn't scale as well as serverless. Sometimes you could kill a database, you kill lots of stuff downstream, right, that can't handle it. If you want to control how much it scales, you can actually go in and say, instead of scaling infinitely, right, I can actually go in and say, I want to, oops, there we go. I instead want to limit my scaling to, I know that I have an old SQL Server on-premise that I'm talking with, I can only can handle 10 instances. And this will make sure that things won't scale past 10. So you can have a few dials on how much it scales, all right? So keep that in mind. And then once again, use Key Vault Manage Identity, please. Don't keep your secret stuff just sitting in a configuration. It's largely safe for the most part, but there are lots of people who have access to, who can and may have access to your Azure portal, and they can get access to your important keys. So with that in mind, and we're right on target here for the last two. The last two are fairly quick. Let's talk about the next one. So the next one, so we talked about Azure App Services, we talked about Service Bus, we talked about Azure Functions. Let's talk a little bit more about that data storage. So for number 4, Cosmos Database. So I get questions, I'm like, why didn't you pick Azure SQL, right? Everybody does relational, right? Well, the reason I picked Cosmos Database is because it was designed for ground up, really, to take advantage of the cloud, right? So it's globally distributed. It is what is referred to as a multi-model, so it supports multiple different types of APIs. So you can talk to the default, which is called SQL, which is really deceiving because it's not a SQL server, but it's a SQL-like syntax. But you can also interact with MongoDB or Cassandra. So behind the scenes, it's all Cosmos Database. But if you have some metaphors that work well, like, hey, I have an existing Cassandra database or Cassandra app or an existing Mongo app, or I just like, and my developers are familiar with MongoDB. I don't want them to learn something new, right? But I want to use Cosmos. It supports that kind of concept where you can interact with multiple APIs once you set it up. The SDK situation is very, very good. They have very good SDKs across lots of different languages. And more recently, there are serverless and other cost-effective options. One of the biggest hits that Cosmos Database gets is it's the impression that it's expensive, and it can get very expensive. But at the same point in time, it's usually expensive, generally speaking, because it's not configured or modeled correctly. I'll talk about that, what that means in a second. So you can actually make Cosmos Database very, very cost-effective. And if you want to play with it, and I don't want to, it can get us, there is a serverless option for it. And it's a relatively new option. I want to say it's still in preview. I don't think it's GA yet, but you can actually use serverless as an option. If you go in and configure it, you obviously won't pay for it. So that's really great if you're just kicking the tires, or if you have some very high degree of variable workloads. But if you want to play around with it locally, there's actually an emulator as well for Windows. So that's a great idea. And behind the scenes, though, this is not a relational database platform, right? This is NoSQL. And NoSQL is really made, well, I shouldn't say it's made, it is really, really effective at making use of things that are important to the cloud, the distributed nature, like I said, the scalability aspects of it, things that, yes, you can do it through Azure SQL and through relational databases. Yes, you can have success with that, but it comes usually at a higher price and it's more difficult, and there's more trade-offs, right? Definitely not bashing relational at all. I mean, I've brought my whole career working with relational databases, right? But Cosmos Database is obviously one of those platforms that is just made from ground up for the cloud. When modeled and configured properly, you can get single-digit response times from anywhere around the world, and that's pretty impressive. There are I know companies that use it instead of Redis for caching because it's so dang fast. Once again, when done correctly, and I think that's the big challenge, and is that the guidance always hasn't been great, especially when it was new, and they've done a lot better job at that of making sure and giving you guidance and ways to make sure that you model things correctly. And I'll hit on that here in a second when we talk about best practices. But looking at it in action here, if we go over to Azure, Cosmos Database, let's not update that. And we open up our Cosmos Database. Where are you hiding here? There we go. At the end of the day, you'll see some various, I mean, this is obviously a similar pattern all throughout Azure. If you're not familiar with Azure, these are blades. Everything kind of looks the same here. And I don't have enough. I haven't hit it enough. There we go. Okay, I should have hit it a few minutes ago. But so it's giving me some options on, like, this is a serverless one, right? I've been demoing this a good bit. So I paid 13 cents in the last hour, right, for this. I don't know if I have a day yet. 7 days. So I spent 21 bucks in the last 7 days, and I've done a lot of demos on this. I've run a lot of traffic through this in the last month. I've used it for various things. So I spent 95 bucks this month, and I've sent a lot of traffic through this. There's probably hundreds and hundreds of thousands of records in here right now. So it's actually not too bad, right? But just kind of be aware that, once again, going back to the comment I made before, where put limits on things, right? If you don't want it to scale for you automatically and you're just playing around, pick a low end tier. And that goes to one of the comments I'll make. So how do we specify a throughput for this? Well, at the end of the day, for them to be able to meet the needs, right, of being able to hit single digit, right, there has to be some assumptions about how much performance you want to be able to make sure that they give you enough resources behind the scenes so that when you ask for it, you can get single digit response. Once again, on a properly configured platform. And with that in mind, they have this concept of RUs. And so RUs are resource units, and resource units can be, you can mathematically figure out based on the size of the data and how many requests you make, how many resource units you make. So you can model some things about how much resources you need. And if you hit that resource, you'll essentially, if you hit the max during a small window, you'll get throttled, right? The nice thing about the SDK, though, is that it'll actually automatically do retries for you. So if you're using the SDK and it only happens occasionally, at the end of the day, you'll have a slightly longer request, but it may come back, 300. It'll try again in 200 milliseconds or something like that, right? So it'll retry automatically if it gets a 429. But you can get metrics and figure out if you're getting throttled and adjust accordingly. And at the end of the day, you got to be a little bit smart about how you configure Azure Cosmos Database to make it cost effective. But from the standpoint of what it does, it's actually really cheap for what it does. And you can get massive throughput through it. And even from a replicate data, I can pick multiple regions, right? I can say I want to distribute it here, 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 here. Now, obviously, you're going to pay a little bit more for the data because it's copying that data around. You have multiple copies of the data. But it means that essentially the issue that you have at the end of the day is you can't beat the speed of light. So if you have customers in Japan hitting servers in the West Coast, there is a bare minimum of latency that they're always going to experience because they can't go faster than the speed of light. And this essentially gets around that. If you deploy your Azure App Services and your Azure Functions and you replicate your data into a specific region, you're globally distributed and you can have a very good experience for geo-distributed customers and users, right? Especially with using this in the back end. Now, I'm really only skimming the surface of this. There's a lot of things that are important to consider. And with that in mind, my quick tips, when you're working with this, if you're new to NoSQL or new to Cosmos DB, throw out relational database. Just get rid of it. Throw it out of your mind. Relational database normalization, all those best practices will just get you in trouble with Cosmos database, cause you headaches, make it cost more, make it perform worse. Just throw them out. There's a lot of best practices that Microsoft has and other NoSQL platforms have in general that you need to kind of apply in your mind. So don't go down that path. Talking from experience, it'll just be painful. Make sure you have careful modeling considerations. If you remember nothing about my whole Cosmos DB talk here, remember in the back of your mind, partition keys are the most important thing in the world. Partition keys are going to define how much things cost, how well things perform, and make sure that when you're choosing a partition key, that it is closely modeled against your use case. So that making sure when you're retrieving data, that it's doing so at the most efficient level and not costing you extra money or slowing things down. Also, keep in mind, duplicating data is okay. We have normalization pounded in our head as a developer, right? But in this case, duplicating data is okay. It's okay to duplicate your data and optimize it for a different use case. And the path of doing that is through something called a change feed. And conveniently so, Azure Functions can be wired into a change feed so that whenever a change gets made to one collection, you can replicate to another and apply any rules you want to it. So there's some great paths for that, for duplicating data. They're generally called like projections is sometimes a term that's used from a pattern standpoint, but duplicating data is okay. And obviously, and I've kind of drilled this in a little bit, understand your cost models. Serverless isn't always the best option. Autopilot, which gives you some kind of, autopilot between certain windows of reservations, reserved RUs, is sometimes smart. Sometimes it's smart just to say dedicated and I'll take care of it myself. I'll schedule it. So during the day, it has a lot of RUs and we follow the sun. And at nighttime, the users are off, so I drop it down to nothing. That might be okay too. So keep in mind about those cost models. Also, understand consistency, right? So whenever you're dealing with any kind of distributed platform, there's going to be latency. And there's going to be how consistent do I need my data? So if I store it in Japan, does the guy or the person in California at the same time need the exact same data? Or is it okay to be half a second late, right? And there's lots of sliders available with Cosmos Database that help you make those decisions and give you some flexibility around that. And lastly, don't be afraid of occasional throttling. It means you're making good use of your environment and you're very efficient and you only occasionally go over your R utilization. That's okay. As long as it's okay for use case, but generally it's okay to be occasionally throttled because it means you're being effective. So with that in mind, this leads me into my last few minutes here of the last thing that every developer, bar none, every developer should know and be familiar with on Azure. And that's application insights. So if you remember me mentioning way at the beginning of this, I said, there's a lot of good things about the cloud. There's a lot of advantages of why customers are coming to it, but there's also some hard stuff. And one of the hard things is monitoring. And because applications are generally more distributed, they're more complex, they have more moving parts, they use different services, having visibility in all of that is super important. And ironically, my day job is a competitor of Application Insights, but I've also been a long-time user of Application Insights. There's definitely some advantages to using third parties, like the company I work for, like other companies on Azure. But if you're not considering third parties, you're just native, you're just getting started, you should always be using Application Insights. If you are looking through log files, or if you are writing in your code, I made it here, I made it here, I made it here, because you're blown up and you can't figure out where it is, you should be using Application Insights. And so it's a fully managed APM platform. That's Application Performance Monitoring, sometimes called APM, is sometimes called Application Performance Management, kind of all the same beast. It's part of Azure Monitor, so it's part of the greater monitoring platform on Azure. It does some neat stuff. It visualizes some of your architecture, and that's great too, because visually understanding where all the moving parts, how they're connected together, how they're talking, and if something's broken, being able to quickly identify what part is broken and what it impacts is great. And one way it does that is through something called application maps. It's also great to get real-time telemetry in, so I can see things flowing in, I can see traces, right? Being able to get snapshots, meaning if something goes wrong, automatically grab a snapshot for me. Let me go into Visual Studio, open it up and step through that code like it was actually running in real time. That saved my butt a bunch of times. And then all the normal stuff that you get really via Azure Monitor, but because of the integration with Application Insights and Azure Monitor, all your dashboarding, your alerts, so that you're not staring at dashboards, you get an email when things go bad. All of that stuff is provided through Application Insights. But let's show a little bit in action here. So if we go to our Application Insights instance, and I have wired both applications in. It's a configuration entry for the most part into the various apps, and it's going to give me some general high-level metrics, right? Response times, different pieces. But if we go here and choose the application map, now I haven't been running this a ton, so yeah, it's kind of a little bit weird. Let's go back a little bit longer here. We can see that's automatically created. We can see here that I have my front-end web app. We can see requests are going to my Azure function, which you've already kind of seen in action. So my web front ends talk to my Azure functions. We can see that service bus is in here. I'm popping messages in here. And at the end of the day, in the code, you'll see that Cosmos database is being stored to Cosmos database. So I've got a complete application map. And imagine if things get even more distributed and more complex, right? How useful this is. And it's telling me right now, there's actually 7 instances running behind the scenes for me. Well, really 7 in the last 7 days. But if there were problems here, this would go red. I can drill into some of the details. I can find my slowest requests. So a lot of things that allow you to make sure that your application stays healthy is super important. The one thing I did want to show you was kind of neat is this live metrics. So live metrics allows you to have mostly real time. It's not really live. It's like maybe like half a minute old. But there's nothing going on right now. But if I go in here and start making requests. So I'm making requests into my platform here. Let's make a request. Let's make a request. Make another request. And if we go back here, boom, we can start seeing, I guess probably should have done side by side. We can start seeing things like traces coming in. I can see some of those. We can see I'm making HTTP post messages. If there were errors in here, I can see error messages. I can see some trending based on not overall health of the instances behind the scenes, but also if there's error rates coming in. I can see that right now there are 2 instances. One of these, I just know from the naming standpoint, is my app services. This one here is my Azure function. Now, if I started doing a bunch of requests here, it is probably going to start scaling on me because once again, it's scalable, right? And so it's going to start saying, oh my gosh, there's a lot of requests coming in. I only have 1 instance. Let's spin up some more. And so in a second here, you'll probably see some more. We'll just push the limits here a little bit. We'll start seeing some more servers, hopefully jump in here in a second. We'll come back here in a minute. But anyway, we should start seeing some scaling kind of things happening. That's kind of fun to look at. But at the end of the day, you should be using App Insights, right? Generally speaking, you don't need to make code changes. Sometimes you need to add a NuGet package to your code. Sometimes you don't. It kind of depends a little bit on what framework you're working with, .NET, Python, different things like that. So definitely go to the App Insights and find out, look at the matrix and see what's supported and what's not supported. But at the end of the day, you should be using this, or you should be using a third-party APM, but you should definitely not be spending your time looking at logs or writing code that says something like, I made it here, I made it here, I made it here, and looking through the logs to see what happened, right? That doesn't scale well, right? And that will not be a good approach for you in the cloud. So as I wrap things down here, what about some tips here? So be careful. It's easy to have lots of App Insights instances. Azure loves creating for you behind the scenes. and next thing you know, you have like an App Insights instance per app. And that's not really what you want a lot of times. You kind of want that big distributed picture. So make sure that you're not spinning up too many and make sure they're all pointing to the right one. Be careful, but turn on your profiler if necessary. Your profiler will give you deep diagnostic details down to like lines of functions of what's performing well and what's not, which can be really helpful when you're trying to figure out where something slow is running. It'll really let you kind of wire into not necessarily a line of code, but pretty close to it of where things are being spent. I alluded to this with snapshot debugging, but there's a great feature that essentially says, okay, an error occurred. It'll grab a snapshot. If you open up Visual Studio, it's kind of a Visual Studio feature. I think something that's coming to code. You can literally, in the end of the day, it's just a memory dump, right? But it's really smartly done so that if I open my code and that code is the same stuff that's running in the memory dump, I can step through it like it's actually running in production. And you're not running in production, of course. You're not remote debugging, but that's really helpful when you're dealing with state-like issues. Like this only happens when Mary Jane logs on. I wonder if it's something with her profile, and you find out, some aspect of her profile is empty because you were able to step through stuff. Also keep in mind, although this requires code changes, and it's worth mentioning, doesn't require code changes on some other third-party platforms. Business events are really useful. Like, hey, I have a checkout, and this is the amount of money in the shopping cart and checkout, right? And then you can start doing alerts on like, hey, what's happening to our shopping cart? It doesn't have as much money going through as it usually does. Or wow, what happened here? Is someone hacked us and ordering lots and lots of money? So there's lots of things, interesting things you can do with business insights. But with that in mind, if you want to learn more, definitely highly recommend check out Microsoft Learn. This is also a fantastic way to learn for free because many of the tutorials on Microsoft Learn will give you a free sandbox environment to do the tutorial in. So you don't even need a subscription. Not all of them, but the important ones, right? So definitely check out Microsoft Learn. If you want to know more about architecture in general, what are the best practices behind stitching together all these platforms? Check out Architecture Center. That's a great place to go to see example architectures of how some best practices behind all these different platforms and how they work together. And then best practices behind building it, like beyond just, I built the app, what are best practices beyond monitoring and cost and all those other things? Check out the well-architected framework, right? And that's a good place to start. So all those three places will definitely set you up for having success as a developer in Azure. This is the demo source. So if you just want to write down Josh D. Carr on GitHub, you'll find Azure source. So all the code that I went through right now and the code maybe you didn't see, plus a simple script that will create the entire environment that I just went on. So literally you can just run this, is available there. And if you'd like to, you can connect with me on Twitter. I have open DMs, or feel free to ping me. I keep Twitter drama-free. It's my professional space. So my Twitter account's very drama-free. So feel free to ping me on there. And also feel free to connect with me on LinkedIn. I'm always happy to connect with folks on LinkedIn, see all the cool things other people are doing. But with that in mind, I know we're coming up on time here, and happy to hang out and answer questions.
Hey, Josh, we had a request. Can you put the GitHub link inside the chat window?
Absolutely. Let me
Do that cut and paste.
good idea. Where's the chat? How do we get the chat from?
Should be the 3 ellipses, I think.
Oh, under more. Sorry. Yeah, it's probably under more, isn't it? Yeah. Chat. There we go. Okay.
Why make it easy?
Yeah, I was like, I don't see the button. Okay, there we go. Okay. And just for reference purposes, so let me just open this so I can show you what I'm talking about in case anybody wants to just play. And this is all .NET, by the way. So if you're not a .NET person, sorry. But all the source code for this is under the Functions and 5 app. And there's a workspace in here. So if you do this in Visual Studio Code, open up the workspace because it'll all be wired up properly. And the deploy here is, and once again, it's a shell script, but so if you're on Windows, you can do it on Windows subsystem for Linux. I got a request here and I haven't gotten to do it in PowerShell yet. But if you open up this, all I'm doing is the Azure CLI. So even if you can't run a bash or on Windows or something like that, if you just want to essentially execute these. Now, one thing I will call out, if you're cost sensitive, you can change this to F1 to be free, right? And other than that, keep in mind that there is some cost behind this. If you just want to tinker around for a day, this will all run if you have a sponsored account, like that $100 a month or whatever it is that they give out for sponsored accounts. If you have like Visual Studio subscription or something like that, I ran this, and I think for 2 hours of playing, it cost me like $8, $7 for a couple hours of playing. So just keep that in mind behind the scenes. If you do run this, there is potential costs. But outside that, yeah, happy to answer questions. And thanks for sticking around. I know I went a couple minutes over here.
Josh, do you have any learning resources that you might recommend?
Yeah, the biggest one, and I couldn't recommend it enough. Obviously, you have your staples, Pluralsight, Lynda, things like that, right? But really, the best one by far is Microsoft Learn. And so, Michael, let's see here if I spell it right. So learn.microsoft.com has this concept of learning paths and learning modules. So learning modules a little bite-sized, sometimes they're half hour, 45 minutes. And they combine into learning paths that can sometimes be several hours. A lot of times they align with certification, but there's just lots and lots of good stuff in here. And for the most part, and they go everything from DevOps to Azure core stuff, just lots of different good stuff. For the most part, lots of these, when you go through them, they require, like the app service one, they give you a sandbox. They give you a sandbox subscription. So you literally go into the portal, and it's a lockdown one. You can't do anything else but the but the tutorials, but it's totally free. And it'll give you some hands-on keyboard time in the portal. And when you're doing them, I think they allow so many hours of usage per day. But really, at the end of the day, if you did like 4, 5, 6 hours on a Saturday, I've never hit my quota. I've done a couple long ones, but that is the best out there by bar none, and it's just really well done. It's a great walkthrough, and they have videos, they have modules. It's just really well done, and it's free. There are some stuff like the Kubernetes one isn't free. There's a couple that aren't free, but in general, this is the go-to place.
All right. Last question for me. In terms of the Azure Developer Cert, any insight into how challenging that is, and is that worthwhile for anyone who wants to prove some of their chops and knowledge?
I think it is worthwhile. I've had mixed feelings of certs over the years, of mixed value. Sometimes they are, sometimes they aren't, and part of it also depends on where you are in your career. I highly recommend it if you're earlier in your career, or if you're making like a role shift, because it makes things look good. I think the most recent ones, the last few years with Azure, have been excellent. The one recommendation is they've tried to encourage a more thought-provoking test format. We all know that there's people that are really good at academic-y stuff and just memorizing stuff and spitting it out. And I think that's what they were trying to avoid in these more recent iterations of people looking at the cert going, oh, that anybody who's book smart can do that, right? Yeah. And so they're very heavy into scenario-based stuff. So here's a story, here's this. They want to know that you can think through these scenarios. So keep that in mind, is that if you're coming from the standpoint of maybe other certifications or certifications in the past where you could essentially read the book, read the docs, maybe open up Azure Portal once or twice and pass the test because you're really good at memorizing stuff, which is not me, by the way. But if you are that person, I'm jealous of you. But that you will not be as successful, right? With these Azure, they really want hands-on keyboard time. They really want you to kind of understand your thought process. And that goes back to Microsoft Learn, all of that stuff gives you hands-on keyboard time, but they also give you a lot of scenarios that are very similar to what you see in the tests. Things like, Acme company has this, this, and this, and they want to achieve this, this, and this. And they kind of walk through that. So that's my recommendation. They are a little hard. Even the low level ones are a little bit more challenging than I was expecting them to be. So they definitely want you to spend the time. There are lots of resources out there. I don't have any off the top of my head that I can share, but Google it and you will find lots and lots and lots of resources of people who shared their knowledge. The one person I will call out, he's on Twitter. He's a good buddy of mine in the UK. And he has some great blog posts. So he's another MVP. He's in Scotland. Gregor Suddy. He's a good buddy of mine, and he has a bunch of blog posts. And he's one of those ones that's like, I'm just gonna do all the certs, and he's just been grinding through them for like months and months and months. And I don't know how he does it. He's a super smart guy, but he's also shared. He has some YouTube stuff and around certs. So definitely check him out. And he's very friendly. You could ping him, and he's good people. So that's one of my recommendations.
Any other questions from anyone? All right. Well, Josh, we certainly appreciate your time. A lot of information packed into that. So thank you much for that.
Absolutely. Thank you for having me. Appreciate it.
All right. Good night, everyone. Thanks for your attendance. As Sam noted in the chat, they will make the recording available as soon as they have it. If that's okay.
Yeah,
Thanks, guys.
we'll
Appreciate
post it
it.
on the LinkedIn. Yeah, and post it on our website and stuff. So we'll send the link round.
Awesome. Well, stay safe, everybody. Stay healthy.
Thanks a lot.
And you, Josh. Thanks,
Thanks,
Matt.
Josh. Take care, guys.